Good. Welcome once again to this tutorial video. And today we're going to be talking about the we're going to be talking about graphical characteristics of function, right? So we have graphical characteristics of functions. Now, what are some of the characteristics we're going to be talking about today? Now, we're going to be talking about the functions as it regards increasing, decreasing. We're going to talk about turning point, local maximum, local minimum, then end behaviors, right? So when you're talking about a function, when is a function f of x said to be increasing or decreasing? Now, note that your function, like we said, let me use this to describe a function. You know, a function, as we said, is always talking about the x and then the y, right? Now, the function is said to be increasing if you choose for some value of x. Let's say, for instance, you choose this point x1, and there's another one point here over here, x2, right? Now, if you evaluate the function at this point, right, and you also evaluate the function at this point, the function is going to be f of x1. Then at this point, the function is going to be f of x2. Fantastic. So if you evaluate this function at this point, you're going to determine if they are increasing or not. Now, then you can clearly say by definition, a function, right? A function f or f of x, now it is increasing. You will say that the function is increasing if it meets some conditions, right? It is increasing on an interval. Now, which interval are we talking about? Any interval you consider. If you're taking maybe from 0 to positive infinity, or you're taking some positive values, maybe 1 to 100 or something, but a function is increasing on that particular interval you're considering, right? Now, if the values, right, if the value of that function, f of x, increases, if it increases as the value of x, value of x increases, right? So which means when I initially evaluate this function, it should be less than when I evaluate the second point, which is x2, right? Now, the condition here is that x1 is less than x2. We can take this particular reference. You see, this point here is less than this point. But when I evaluate the two functions, this function here is less than this other function. Then you can say that this particular function is increasing. You understand? So that means that as we move from left of this graph to the right of this graph, right, the curve and the value of the y coordinate is increasing. So for example, if I have the function looking this way, like this, you can see this function is what is increasing. At this point, it is here, but at this point, it is going up. So you can say this kind of function is what is increasing. Good. Now, let me take out this one. Now, we can also give another instance when it is decreasing. So this is for increasing. So a function is decreasing. So a function is decreasing. A function is said to be decreasing if the reverse is the case, which means I have a function evaluated at x1, But at this time around, it is greater than when I evaluate it at that second point, and provided that my x1 is still less than x2 within that interval, right? Within this interval, within the interval of consideration. So let's take, for instance, I have a function this way, right? So I have y, I have my x over here, and then this function is looking this way, right? Let's say this function is looking this way. Good. Now, if you look at this function, from this point over here to this point over here, you can notice that there is a decrease, right? The value of this function, if we take here to be our x1, and we take here to be our x2, definitely this one is going to be in the negative direction, which means x1 is less than x2. This is checked. But the value here is going to be x1. This value here, the value over here is going to be what? F of x2. Clearly, we can see that f of x2 is greater than, is less than f of x1. F of x1 is greater than f of x2. So this function from this interval over here, considering just this interval, we can say it is what? Decreasing. So that is that about increasing and decreasing of functions, right? Now, we can now go further to state what is a turning point, right? Now, a turning point is a point on a curve that is higher or lower than all the nearby points. Now, it is either it is higher or it is lower than all the nearby points, right? But the clear objective of turning point is to actually indicate what we call the local minimum and the local maximum, or global minimum or global maximum. So let me use a graph to demonstrate this particular concept. Now, if we have a graph looking this way, let's say this graph is looking this way. Now, we're talking about turning point, right? Turning point. Turning point. So on this graph, you can consider this point over here as a turning point, and over here also, there is another turning point. Now, in this case, this point over here is like a maximum. This is the highest point, as you can see, because we don't know if there is another turning point over which you can have any other one. Now, this place is called a local maximum, and this other place is called a local minimum. Now, if I have this particular point, you see it is higher than the local maximum. If I find out that this graph turns back to this point, assuming this graph turns back to this point, then this place automatically become the global maximum. Now, it is global because except there is another turning point somewhere with which we don't know, considering this interval that we can see, this is the highest point where that we have a turning point, then we can consider this as a global maximum. We have seen that this graph did not surpass this particular region, so we can consider it as a global maximum. So a local maximum occurs when the function changes direction from increasing to decreasing, right? So that is the definition of a local maximum. It changes direction from increasing to decreasing. You get a local maximum over there. Then similarly, you get a local minimum. When the function now changes direction, right? It changes from decreasing, then it started increasing. Then you can say you have a local minimum at that point. Then lastly, we are now going to be talking about end behaviors. Now, end behaviors, it has to do with observing your graph, right? You're observing the function or the graph or whatever, and then you want to know what happened to the function as the value of x gets so extreme, right? The value of x gets to infinity, whether to the positive side, which we know, or the value of x as is going to the negative infinity, which we actually indicate as this. What is going on, right? So as x takes very large values, positive values, we say that x tends to positive infinities. If x is taking large values to the negative direction, we can say that x is going to negative infinity, right? So if I should consider this graph over here, I can say that for as x is going to the negative infinity, if you're considering this is 0, and this is the x-axis, this is the y-axis positive, this is the y-axis negative, this x-axis in the negative direction. I can say as the value of x is going to the negative direction over here, the function, as you can see also, is going to the negative direction, right? So I can simply write, I can say that as x tends to negative infinity, my f of x actually tends toward negative infinity also. That is the end behavior, right? That's the end behavior we are talking about. So let me give another example over here. I have a function looking this way, right? So this one is going up, right? This function is going down. Considering this function, you can see clearly as x, this is the value of x. Now, if this function, right, this is x, I can clearly say that this function as x is going to positive infinity. This function f of x is what is also going towards what? Is this positive? Is this positive? This is going to the negative side. So it's going to negative what? Infinity. Similarly, if I'm talking about the left-hand side, now I can say as x is going towards negative infinity, because this is the negative part of x, right? Let me extend this, right? This is y, this negative part of x. As x tends to negative infinity, the function f of x also is going toward, this is positive right now. So we can say it's going to positive infinity. So that is how we consider the end behavior. You see this? This is the end behavior. At is going extreme, you consider the end behaviors. So that is that about end behaviors. Oh, good. So you can use some other functions, some other polynomial functions, play around with them, talk about their end behaviors, and then I will see you in the next class. I will see you in the next video. If you have any challenge, you can put it down in the comment section, and you can watch other videos to get more clarification. Thank you. Please remember to subscribe, like, and share.